I'm going to talk about the theory of constraints and lean. How many of you have read the original book about the theory of constraints, which has been published in 26 languages, 5 million copies, called The Goal? I don't know how you say it in Lithuanian. Okay. How many of you have implemented the theory of constraints? How many of you have read a good book about lean manufacturing? How many of you implemented more or less or started more than halfway implementing lean? Okay. I don't know. I can see how many hands are going up. I'll summarize. About a dozen people have read The Goal. Nobody's done any theory of constraints. About 20 people have read lean books, and about 30 have done some part of lean. Okay. The presentation is very simple. I'm going to do a brief introduction and then look at two different cases. It's always difficult when one's talking about these things. Did I choose the cases right? You know, is somebody in the process industry or in chemicals or in an assembly or in an engineering product, are they going to think this is not for them? I think that you'll find that these ideas are fairly universal, and whatever your business, it's pertinent, but I had to choose just two cases. I've been learning lean now for over 25 years, and I've been learning theory of constraints for over 25 years. And from a long time now, I've always been doing the two simultaneously. And as I say, I think it's surprising how people seem to consider that they are separate and incompatible, when in fact it's so easy to put them together. It's mostly a question of mindsets or politics and that sort of thing. But when you think about it, there's no reason you shouldn't be doing both at the same time. And that's the subject of the presentation, because if you do both at the same time, you very quickly improve. You can improve with an injection of theory constraints into a lean system, a lean approach. You can improve results much, much faster. Okay, that's what I'm going to try and show. I've written a very boring book about doing that in French in manufacturing, and I'm fairly active in the TOC world and in the lean world in various ways. And I don't speak any Romanian or Lithuanian. You've heard everything I know about that. Christoph this morning presented what the theory of constraints is all about. He had a piping system that was horizontal. I have a piping system that's vertical, or rather a system of tanks in which water flows from the raw materials to finished goods. And, well, as I say, I do so much of this sort of thing that in fact it's the company logo. Why are things like that? Does everybody agree that your systems, your organizations, your factories are like that, and you cannot balance your system anymore? Is everybody at ease with that idea that it's become impossible to balance an organization, and one is always faced with non-bottlenecks and bottlenecks? Okay? So we have these two resources. And what I'm going to try and show with these two examples is what happens if you just realize that that is there, and that's where you must start working. Okay? And the very important thing that that allows is, because you focus on that, okay, you don't have to solve a little leak up here. That's not a problem. You don't have to solve a problem that this sometimes breaks down for 5 hours. That's not the problem yet, okay? The problem is what's happening here. Okay? Maybe the question was asked, or the discussion has occurred in other presentations which I wasn't in, but nobody seems to be asking how many constraints I have in my system, which is often one of the first questions that occurs. There are a lot less than people think if they haven't started using the theory of constraints. People will tend, if they've never tried, to say, ooh, I've got about 30% of my resources that are critical or important or bottlenecks or constraints. In practice, you only get about 1 or 2 in a factory of, say, 500 people, okay? Just 1 or 2 machines or 1 or 2 pieces of equipment often. In the 2 cases I'm going to be presenting here, the constraints are in the factory. There is a bottleneck. If the bottleneck could produce more, we could sell more, okay? I live in France and work a lot in France and England and Western Europe. That's become fairly rare now, okay? The bottleneck is now often in the market. That's one way of putting it, okay? Or to put it in another way that the theory of constraints prefers, the bottleneck is probably somewhere else in your organization than in the shop floor. It could be that your products are not good enough and you need to boost your new product development to get the new products with the new technology or the new whatever to make them more attractive. Or maybe your marketing and sales is not efficient enough. You have pretty good products, but you've fallen asleep because 5 years ago they were easy to sell, and now you really have to do some marketing. You really have to do some selling. You don't wait for people to phone anymore. Okay? But I'm going to concentrate in these 2 examples on what happens when you're in the position where the bottleneck is on the shop floor somewhere. The other point is a lean point, or more a lean point than a theory of constraints point. And it goes back a long, long way. One of the beautiful, simple ideas of Taishi Ono when he started his Toyota system, which is you can never have too little inventory on your shop floor. You should always, always be looking to reduce it and reduce it and reduce it. I don't know what you know about some of the best examples within Toyota about how far they've gone, but in quite a few manufacturing processes, the time between the first operation and the finished goods is in minutes. And for instance, it can take them now less than 50 minutes to make a car engine between all the parts arriving at the factory and the engine starting at the end of the line, okay? That's how far they go. It's taken them dozens or decades to get there, but they always do that. Now, why do they do that? If I use Taishi Ono's analogy, the most famous is the river analogy. Sorry, I'm an engineer, so it's a very non-artistic river. If we imagine one's factory as a river in which there are rocks that represent problems, like long changeover times or machine breakdowns, and the water flowing through the river are your products, okay? Taishi Ono said, live dangerously, reduce the level of your water to make your problems emerge, deal with the problems, okay? Here we have lack of flexibility in a machine, and so we must reduce the setup times. And once we've solved that problem, again, we reduce the level of the water until something else happens. Oh, we have a problem with machine breakdowns here, okay? And that's the process of ongoing improvement of lean. And you should get very, very, very low. Why do you do that? Because if you do that, you have to get your quality right first time. Any form of waste will usually be eliminated, whether it's distances or whatever. And anyway, to keep it very simple, if Toyota was wrong, they would have gone bankrupt a long time ago. Okay, so they're right. Cost accountants won't understand that, but you should always be reducing your inventory, even when your inventory is in minutes. I mean, ask a cost accountant why I should go from 55 minutes to 50 minutes of stock, and you'll say there's no point. Okay, but Toyota does it, and it's winning doing it. Okay. Now, there's no incompatibility between lean and theory of constraints on that point, because normally the theory of constraints, the goal is to increase throughput while reducing inventory and operating expenses simultaneously. Okay, so the idea is there also in theory of constraints, but maybe it's carried more, or it's been implemented in a more complete fashion in the world of lean. The main difference, really, if you look at a lean and theory of constraints, is how it manages product flow. Okay, I won't try and explain how Kanban works, but this is the system within theory of constraints called drum buffer rope. The idea is you identify your constraint in the system. You then decide how you're going to beat the rhythm of your whole factory, the drum. Okay, and that should be in a perfect world, linked to the orders coming in and your order processing, so that you know exactly when it's going to be processed on the critical resource, the constraint. And then I'll come to the buffer in a second. The rope is the thing which will decide when one will launch the raw material that corresponds to that particular work order. Okay? So if we assume that these operations will take about 1 hour each, or exactly 1 hour each, then if I want to do that at 16 hours, I will subtract 5 hours of work and I will launch it on the 11th hour. Okay? This is when I said 5 hours, I meant the actual production time. Okay? I added no waiting time, no other kinds of times whatsoever. That's machine time on each of the operations. Okay? Now, if I ran the factory like that, of course, it wouldn't work, would it? Because there would be a problem here, there would be a setup, there would be all sorts of little problems, and the product would arrive too late for the bottleneck, so we add a buffer. The buffer here is to protect the bottleneck so that it can work as was expected from any problems that they have on the non-bottlenecks. Okay? And that protection, you can have an hour, you can have days, you can have, in some systems you will have weeks, and that sorry, I have a cold. That protection will depend on the level of variability that you have in the processes before the bottleneck. Okay? There is a second type of buffer in the system, which is to make sure that your due date performance, the timing of your orders coming out to be expedited and go out on the trucks and stuff, to make sure that everything is on time here, you can add a second buffer, which is calculated according to the variability that you have in that area. Okay? And normally, tuning these systems, whether it be a good Kanban system or this, will give you very low inventory and very good output, very good throughput. Okay? And it's true, this is the big difference between a Kanban system of lean and the drum buffer rope of theory constraints is there. But it's only that, basically, in terms of a difference. There's very little else that's incompatible or very different. As I mentioned down at the bottom, if you don't have a constraint in the system, if you don't have a bottleneck, you use the same logic, except you get rid of this protection here because you don't have a bottleneck, and it's called simplified drum buffer rope, or sometimes SDBR. It's exactly the same logic, except since it notices there isn't a bottleneck in the system, it just has a buffer in the shipping dock. Okay? Case study number 1. I hesitated because I find people talk too often about the automobile industry, but I decided to put this one in because it's interesting to see what theory of constraints can do when it's injected into a very good lean system. Okay, that's the first story. It's not written in any of the slides. The company is called Verslo. It's about now 14 million euro sales, about 100 factories, and it produces various parts of cars. And they are of French origin. They're very good at lean. They started in 1970. I've worked in many different organizations, and they are truly well past the halfway mark and starting to look a little like Toyota. Still a long way to go, but I mean, it's a very lean organization. Okay, so all these things are current practice, and it's natural, and it's been like that for several decades now. Okay, we're going to talk about a factory that produces the alternators for cars, a factory of about 1,000 people in Mexico. They had a problem, which was in 2011. They couldn't produce enough to supply the whole of the American continent as they should, and they were starting to stop Detroit. So people like General Motors got very, very upset. Even though they were already sending everything by plane, they sent a permanent team that was there 24 hours a day, 7 days a week behind every machine to make sure that the factory would never stop. They'd sent 10 of their best production managers from around the world in as well. So I had 11 plant managers simultaneously, which was quite an experience. They were already building a second factory to go from 1,000 to 2,000 people and double the output. And they put as many people as they could physically fit into the lines. You just didn't have any more room, right? And yet they were still late. Okay, so this very lean, very proud to be lean organization, so about to lose General Motors as a client, said, okay, let's try these strange ideas with the theory of constraints. We don't have any other ideas. What have we got to lose? We went in and had a look. The factory was a green site factory, so everything was laid out just like in all the good books. The rotor, the part inside that turns, was produced on one side of the factory. The casing, the box, was produced on the other. And a quick analysis identified that there were within the 20 different production units, about two and a half of them that were bottlenecks. Okay, and I'm going to tell you about this one. So it's a U cell producing the rotor of the alternator. It's about sort of this size, about 3 kilos. The product comes in here and goes around what would be called a U cell. Comes out here. The various parts are added little by little. It goes through an operation in an oven here. It's nearly finished coming out here. Here they have to balance it to make sure that when it spins very fast, there's no vibration. And then they finish it and come out here. Okay. It is already in the Valeo production system way of doing things that they have identified their bottleneck. There was a sign up next to the machine saying this is the bottleneck here. Okay. And there were 2 other resources that were potential bottlenecks not far behind. Okay. Very little breakdowns. The OEEs were well over 70%, and they wanted to produce quite a lot more. So what should you do? They had as many people as they wanted. There's a nice one-piece flow going around. I haven't shown the conveyor belt, but there was a conveyor belt going around, so that, beautiful one-piece flow. Pretty good results. How can we produce more? Overall equipment efficiency, what percentage of the time it actually works, right? Within 24 hours, it worked 22 out of 24 hours, so it's 22 over 24% efficiency. Okay, how can we increase the production by 15% in 15 minutes? They don't walk. The products go around on a conveyor belt. "15 minutes. What can you change in 15 minutes? A rule. What rule should they change? Yeah, bottleneck should work 100%, and to do that, how do we make sure the bottleneck works 100%? It already had as many people as it wanted. There was standing room only in this factory. You heard the jokes about Mexican armies and stuff. There were people everywhere. Put a buffer before the bottleneck. That's all we did. Well, first we confirmed that was the bottleneck. Okay, in this very lean organization, we put 12 parts, about a queue of about this big, in front of the bottleneck. Okay, from that moment on, it stopped having micro stoppages which weren't written up anywhere. Stoppages of less than 3 minutes, 40 seconds, 60 seconds, 2 minutes, which nobody had even time to write about anywhere. Okay, and immediately we started producing 15% more. So the trick in my question was they had beautiful one-piece flow everywhere. You don't want to put one-piece flow in front of a bottleneck in this situation, especially in this situation where that was nearly a bottleneck and had little problems. And so when that had a problem, it stopped that. And when I lost a minute there, it was lost forever. Okay, this is, I repeat, a very good, very lean organization with machines that were basically working very well, very good quality, but there was nothing to see unless you, well, I did a 4-hour Gemba study, Gemba walk to make sure that was the problem. But there were all just these tiny stoppages, sometimes 5 seconds, 10 seconds, 15 seconds, 40 seconds, and the whole thing turned up to be 17% increase immediately. Okay. Now we didn't stop there, but I won't go into further details. We then added the rule that the bottleneck must never stop 24 hours a day, and so that when the shifts changed over, when people went to lunch, we added just a rack of about half an hour's work to make sure that that machine, even if everything else stopped, would work 24 hours a day without losing a single minute. Okay. I don't know how easy that is to do in Latvia. In France, it's getting quite difficult to do, but in Mexico, it's easy. No problem. Okay, so that's it. I repeat, 15% increase more or less immediately just by changing a rule. An important rule for anybody who's very keen about lean, where I was ripping a page out of the Bible of the value production system, which said, one piece flow everywhere. Okay, but in this situation, that went a long way to solve their problem. Okay, so that's just a bit of a TOC injection into a very lean system. But I always worry about talking about too much about automobiles because we don't all of us produce automobiles or parts of automobiles in large quantities and so forth. So I wanted the second case to be very different. Okay, so this case is a little factory of 300 people in the Glass Valley of France in Normandy. Glass Valley because that's where most of the glass manufacturers are for historical reasons. And it's an old factory founded in 1892. They produce perfume bottles, the very high-end, very expensive perfume bottles that basically nobody else can make because they're so complicated. And they have all the big perfume manufacturers as clients. Okay. The machines, they have two processes basically. For very small quantities, they have a manual operation. And for the larger quantities, we're never talking about huge quantities, right? But for the larger quantities, they have a semi-automatic process. And for those who've never been into the fascinating world of glass manufacturing, that's molten glass coming out from a furnace, being formed in these slots here, and being knocked out to go on to be cooled further down the process. That was the bottleneck. They did an analysis, okay. They had plenty of capacity in cooling inspections and up in the furnaces above. That was the bottleneck. So, what do they do? Well, it's the machine that takes molten glass and puts it into a mold to give it the shape of a bottle. Okay? A very complex bottle, right? We're not talking about a bottle of beer. It's all sorts of funny shapes like complex perfume bottles are. They didn't have enough capacity. Okay? And they had very poor due date performance, and that was their problem. But they could if they could produce more, they could sell more. They had new management that was already experienced both in TOC, in Lean, and in Six Sigma. And in fact, a fairly unusual organization at the board level because there was a director of quality and TLS, TOC Lean Six Sigma, okay, which is, I think, fairly rare in industry today. This person having done in many previous organizations the integration of theory constraints, Lean, and Six Sigma, and I'll show you how that's done. So they had a house inspired by the Toyota house, okay, with its various pillars. And I haven't attempted to translate it. There wouldn't have been that much point. But that's all about bottlenecks here. And that's about Six Sigma. And basically the rest is standard lean practices about, standards, about Muda hunting, about maintenance, about tack times, about all these sorts of things. Okay, they have a completely integrated system where they don't look for the differences. They try and integrate theory constraints, Lean and Six Sigma. And one of the areas where it's the most visible, and the reason it enables them to go very quickly, is in the way they decide what projects, what improvement projects they're going to run. Okay, and they just use the basics of theory constraints idea, which is, let's take a system or a company-wide view and decide what is important, what are the constraints, and what is not. Okay, and then with fairly obvious indicators, they calculate how much money I would make if I succeeded that project, how much money is required to do it, how much time it's going to take, is it going to have an impact on customer satisfaction, is it going to have an impact on employee satisfaction, and then they have a multi-criteria selection process that enables them to choose their different projects. Their major projects, for instance, being, if I go back to 2012, they decided on 17 priority strategic projects in this fashion, okay? And 2/3 of those 17 projects concerned the bottleneck. The rest was not important, not yet. And it's as simple as that. If you want to go fast, don't work on things that are not going to change the global performance. The Lean side, just to show you a bit of Lean, they had good visual management throughout the factory. Sorry, it's not really visible as a slide. That's quality, cost, due date performance, security, and management. That's a day-by-day, shift-by-shift visual management system to make sure that their performance is good. They did a lot of training. They used 8D. I don't know if people use 8D at all initially from Ford to handle client claims. And they did a lot of 5S. Again, I'm not sure the pictures show clearly, but it was fairly awful when they started, and it improved significantly. And we can talk about 5S if you want. It's one of those things that's easy to talk about here in a conference room, not easy to see properly implemented, practiced by everybody perfectly throughout the firm. But they did that without any particular problems. One of the reasons I chose this is that there is this other thing called Six Sigma. And should that be part of the cocktail? I believe that TOC and Lean are the fundamental elements that should be universally applied in the cocktail. Six Sigma really depends a little on what your business is and what your problems are. In this case, the bottleneck that I described was a complex process where the materials going in, the kind of sand, the kind of glass you're using, the temperatures and so forth were very complex. And to properly master that process, there was no other technique than Six Sigma with design of experiments and playing with it all until they understood how it worked, and they could tweak all the different parameters to significantly increase. In fact, the scrap rate, they had a very significant scrap rate before they did the Six Sigma. They would inspect the perfume bottles at the end, and a lot of them, won't give you the figure, but well over 20% were just thrown back in, do it again. Okay. Six Sigma done on a bottleneck is a little different from standard Six Sigma in that most of the time people talk about using Six Sigma to reduce variability and better master the process. But when you do that, very often you discover how much more you can make with that same equipment, okay, because you understand how it works properly and you're not wasting its potential. And so in this case, and I've done several like that, what is remarkable is how much extra capacity you will get out of your same asset because you've mastered it better and you know how to use it properly, and you can get 20, 30, even 40% more out of the same machine, okay? And if it's the bottleneck, that's a gold mine. So that's what they did, and for instance, one of the vice presidents of Procter & Gamble said these people turned the art of perfume bottle making into a science. It's true, they did a lot of great work. which they keep very secret about the parameters they actually use, but they got pretty good at making sure that the scrap rates are very reasonable. In terms of results, I didn't mention the results of the first one with Verslo. That saved the relationship between General Motors and Verslo and was worth a lot of money. In this case, their increase in sales and profits are better than that. In sales, it's about 13% a year, a lot less than some cases that we were presented, sorry, but they were pretty proud of that. It's good, stable growth. And apart from those financial metrics, there was a reduction in inventory, in work in progress and finished goods. You can easily be disappointed with the figure 20%, but in this kind of process industry where there wasn't that much inventory in the system initially, because it's all hot glass that goes straight through the system, right? You didn't stock molten glass anywhere and so forth, so getting it down to a further 20% was a pretty good performance. The same ideas applied to more manufacturing systems where stock will be stored between operations. You would have necessarily more like 80% reductions, but in process industries it's more constrained by the nature of the process. They did SMED, or rather process SMED, because the machines are complicated, many people are involved. It's more like a mini project changing over, and so they used an evolution or an adaptation of SMED for a complex machine to reduce the changeover time. And they had significant increase in quality. They used to have too many batches refused by their clients, and quite quickly they got to very reduced. In fact, that's 2011. 2012 they got to below 1%. So they really got their quality under control. Any questions on that second case? Yes, they reduced significantly the minimum order and the production batch size, because and that helped create a fairly good competitive edge with regards to their competitors, because it was one of the problems with this kind of industry was that I think Ellie gave a couple of examples. We had one where the batch size was recalculated for a perfume that was sort of at the end of its life. And when they did the calculation as how much they just produced, they worked out that it would take 15 years of sales of that perfume before they'd finished their batches of bottles. Okay, and it was leading to problems with their clients, because in 15 years, given the fact that the bottles were stored in a warehouse, there would be flies in the bottles. And that wasn't good for selling perfume, so it was a big issue. Yeah, they reduced their batch sizes by, on average, 4, but sometimes by about 20 for the end runners, to make sure that there wouldn't be any very old obsolescence. One of the things I'd like to say hasn't been mentioned much, I think, so far in this conference, is about local optimums and the real problem about local optimums, right? Theory constraint says, watch out, the sum of local optimums does not equal the global optimum. That's to say, if you keep everybody working full-time everywhere, that doesn't necessarily give you the right system performance. Is everybody happy with that? Okay? And then there's this easy part, which is find the constraint and make it work all the time. That's the easy part, because it goes back to the reflexes of the good old times where you had to make lots of products and keep everything moving and stuff. The real problem is that about 80, sometimes 90% of your factory are non-bottlenecks. And they should not work all the time. That is the really difficult thing for managers to live with. And we had a good example in a previous conference. What you do when in fact you're ordering somebody not to work. You're there, you're paid, don't work, don't produce. Okay, and that's, I think, the biggest problem with implementing these sorts of ideas, in particular in production, is how management can learn to live with the fact that he doesn't have the easy facility like he had before of just keeping an eye out on everybody and making sure everybody's working all the time. Okay? And it needs to lead to probably a culture in which those people are asked to try and contribute in terms of improvement actions and not just producing. And that involves having another regard, another way of considering, of looking at one's workers as one's workforce, not just as arms that will make and produce, but are capable of initiatives, of maintenance, of improving the product or improving the process. And that's a big challenge for a lot of management, I think. Okay, so watch out. The bottleneck focus and everybody do things on the bottleneck, I consider to be the easy part. The difficult part, and if you don't do it right, it will never work, is what you do with the vast majority, 80, 90% of your workforce, for whom you're no longer asking them to work all the time. In the first example, there was a 30% extra capacity, excess capacity in half the factory, all the right side. Okay. Some managers would have been very tempted to reduce headcount by 30%. Yeah. Okay. That's not the option. If you're doing that, you're lying to yourself. I come back to the question I asked you at the beginning. Do you think you are capable of balancing your factory? If the answer is no, then don't forget that 2 hours later when you try and go from 5 people to 4 people in one corner of your factory. Because in fact, you're trying to balance your factory, aren't you? And you can't. You all admitted it. It doesn't work. All you can do if you work it that way is create bad bottlenecks, right? And you've taken one person out in one corner. In fact, you've reduced the throughput, the capacity of the whole factory in a bad place. But it was your decision. And that happens often, as I repeat. The problem with the theory of constraints is not the constraints, it's the non-bottlenecks. It's the idle time. I don't know what the Lithuanian translation is for idle time, but in English, idle time is a criticism. You're being idle. You're not doing anything. The second point is, as far as I'm concerned, I've been doing this for a long time, and when I discovered Lean and then TOC, I naturally, from the beginning, just did the two at the same time, and I just can't understand why people consider that there might be some kind of incompatibility, apart from some of the details of the synchronization mechanism, right? Kanban versus drum buffer rope. But I mean, if you've understood Lean is a lot more than just Kanban, isn't it? Okay? So what's the big difference? What's the big problem? Okay? Give you another one to understand better. I often make the difference between good Lean and bad Lean. Good Lean is, for instance, Toyota Motor Company, and it is a system in which what they do is to fuel growth, to become a bigger company with, if possible, #1 in the world. Okay? And bad Lean is the same system used to reduce headcount, to die slowly. Okay? I have 100 people, I do a Lean program, and now I'm 10% more efficient. I fire 10% of the people, and next year what do? Hey guys, let's do it again. That's not the Toyota model, and of course it doesn't work. Okay? So if you forget bad Lean a second, what is the difference between Lean, done by Toyota, and theory constraints, which talks about the throughput world and increase your throughput, increase your sales? Toyota has always been trying to increase the sales of its vehicles and still will. Okay? So good Lean also looks to growth, to be an entrepreneurial growth system. It's only bad Lean that seems to be very incompatible with the throughput world of theory constraints. And watch out, bad Lean doesn't work. So, why that difference? I'm afraid it's quite a lot to do with people like me, consultants, experts, and so forth, where People seem to think they have to be part of a lean chapel or a theory of constraints chapel or a Six Sigma chapel. I'm sorry about that. I apologize in the name of all consultants and thinkers and stuff. But if you think, for instance, again, about Toyota, Toyota was always trying to pick up ideas left, right, and center and bringing them in. I don't know if you know the idea of Kanban came from American supermarkets, for instance. So you should, pick and choose a little bit of this, a little bit of lean, a little bit of that, a little bit of the Vilnius way or whatever, and build your own systems. And beware of falling into one particular school of thought and saying that because I'm doing this, I'm not doing that. Because frankly, I see no reason to exclude, in particular, theory of constraints and lean. They're just made for each other. Often I'm asked, if I had to go away on a desert island and I had a factory to run, which would I take with me, lean or theory of constraints? I'm not sure. I'd probably take lean. Theory of constraints just tells you what to do, doesn't tell you how to do it. So at least I'd be able to do things. I might do it slowly and stuff, but I mean, theory of constraints doesn't have SMED, doesn't have the Gemba. I couldn't have done what I did in the first case without Gemba, without going out and standing there in front of the machine for 4 hours. And that's lean. That's not theory of constraints. So they just fit together. I've never understood why people don't see it that way. And if you put them together, it just goes very fast because you hit the right spot. I don't know if you know one of the ways people talk about this focus and leverage of the theory of constraints. It's often called 1%, 99%. Before that meant something else. But it's a comparison with Pareto, 20%, 80%. And theory of constraints, you can act on 1% of the system to get 99% of the result. It's not mathematically sound or anything, but it's just the power of focus. Okay? And once you're focusing there, you'll probably be using all the mentality, all the tools, all the lean approach to do that, because it's very, very good at cleaning up, getting to perfection, getting rid of all kind of waste, whatever it is. It's a reminder about the books, what the 5 focusing steps are. My view of what the theory of constraints is, all of it. We've only talked about this part here. Other conferences have been about critical chain. Other ones about replenishment and distribution. There's more about marketing, throughput accounting, some today, some tomorrow, the thinking process and so forth. More case studies. That's an Autoliv TLS case study. That's a steel industry case study. Recommendation on this book, if you're interested and want to go further, there's a book which is half a novel or 2/3 a novel and 1/3 a textbook summarizing the principles of integrating theory of constraints, Lean and Six Sigma. Well, that's very recent and good. You can, but watch out. I might be advertising my own humble self. You might be interested in LinkedIn group for those who use at all LinkedIn. There's a TLS TOC Lean Six Sigma group, but I founded it, so don't ask somebody else for its credibility. But there's a lot of interesting things going on there. A reminder of what the various systems are. A bibliography of the best books of theory constraints, of Lean, of TLS, and that's it. Okay, just to say that I think these ideas have been around for quite a while now, and it's silly not to read some of the books. It's my way of looking at these things. Lean can, at last, it took some while, but Lean can be understood by a few books like Leica and other stuff, and there are books on theory of constraints. So if you haven't read some of those books, they're well worthwhile. Don't worry, you don't have to read them from page 1 to 300, but just play with them for a while, and I hope you'll find interesting ideas then. Thank you very much.